So it's Monday. Yesterday I spent about 4 hours on a D'Amico convoy, and we've got a receive problem on that, and I'm waiting for parts again. So that's not happening. So we're going to move on to the second of the Maxcom 16Es. I did find the power connector pushed inside, so I don't know whether that's a snag with the set. We can replace the connector. Or we can hot glue it into position. Right, of course I don't have PA on these. So it comes on, it's on 19, and we need to plug a mic in. So we use our Comtron mic. Sounds a bit detectorish. Not the normal kind of FM noise. So if I've got any idea where the clipboard is, it's behind you. It's like a pantomime here. 1st of September. Set 2 of this customers, just so I remember. It's in very nice condition. 2086. It's March 82, and it says London on the back. E49RR. Ooh. Cool radio having been to London. I don't know. Right, let's put it in normal power. Switch picture in picture on. And we'll go on the 3 watt scale, and it's doing 2.8. 2.8 watts. Back to channel 40. 2.8 watts. Channel 1. 2.8 watts. That's pretty balanced. Low power. 260 milliwatts. Which is about 10% of the high power, which is where it should be, but it should be 400 milliwatts. And the current consumption, let's go back to channel 20, 1.006 amps. Deviation from what it's worth on this test set. Wow, it says 1.5 at this point. We know we'll be doing the VCO. The frequency of the test set's been on more than half an hour. 27,79099. So it needs pulling up, but it's not noticeably off frequency, and it's certainly not illegally off frequency. So with that figure, we'll go into the signal generator and put the same signal on for fairness. Let's put the SINAD meter up. Mice have moved it. Oh, this is alright. 0.62. Anything under 1 microvolt on the Maxcom chassis is acceptable. 10 dB, 0.59. It's one of these sets, if you touch it, it alters it. And for 20 dB, it's 0.92. Right, squelch. So taking the squelch to full. Let's put the attenuator up on the screen. I want it to be 100 microvolts. 1, 3, 10, 30, 100. No opening. It does open at... It opens at 43 millivolts, which is somewhat harsh. Let's look at threshold. So we'll drop the signal generator right down to 0.3, park it there and switch it to standby, and on the radio set the squelch threshold. It's 0.65, which is fine. However, that needs moving. Now, signal meter isn't usually adjustable on these, but it can be. For 100 microvolts, it is 290 microvolts. So it's what's... I'll put it in the wrong box, 290 microvolts. While we're looking at the meter, let's go to transmit. And it's correctly reading 4, even though the set isn't doing 4. So it doesn't have a meter lamp, switches work, potentiometers work, sockets work, it doesn't have PA. So it's coming with a microphone, but we're at this stage going to be doing it on our test mic. I have to admit, I haven't seen the customer's microphone recently. Oh yeah, I can see it. It's here. So we'll take the lids off. It'd be interesting to compare the two with the specifications when I've done this. I'm not sure why that's happening. Might be tempted to replace the socket. By the time it's pushed through loads of times, it may well be worn. So we'll go for transmit. So the multipliers, etc., up to there, and then we start doing the PA, the power amplifier, and power set on that final one. If we don't quite get 4 watts, we've just got to make sure that these airspace coils aren't messed with. I don't think we got... I'll tell you what, let's get the clipboard back to the page for the Maxcom 16E. It's there. Yeah, it's about the same. The other was receiving better. 290 microvolts, exactly the same. So we ended up with 3.6 watts on the other one. I'm not even showing you the right meter. Right, we'll go back to the third one. 2.95 at that point. That's the 3 watts. Go over to the other scale. So now on the 30 watt scale, so we're down here, there's 4. So we'll heat up that one. About 3.4. Ooh, very close. That's 4. Difference between 3.6 and 4 is so marginal that it probably won't make any difference whatsoever to range. Don't think it's a percentage of, you know, don't think if you get 3 watts instead of 4 watts you only get 3/4 of the range. It doesn't work like that. Just like if you have a record player with a 2 watt amplifier, you couldn't compare it with one with a 2.2 watt amplifier or one with a 1.8 watt amplifier because it won't make any difference. So there we are, it's a good 4. Right, channel 40 is also 4, channel 1, 4.02. It's within measuring tolerance, so okay, so on the power meter back at channel 20, it's now banging across. We'll adjust it. It's the lower one of those presets to be for 4, just on the edge of 4. And I keep saying when we put the aerial on this and I key up, it won't say 4 anymore. In fact, it doesn't now, does it? Do that adjustment to get TX light works on this one. It costs him less work. So when I put this on the aerial, it may not read 4, it may read 1, it may bang across to 5. It doesn't mean the set's doing any more or less power because it's only calibrated on a dummy load, which is what's in the test set at this point. It's a relative power meter. I said in modern sets it's pre-programmed, it just says what it's programmed to say. You can even take the works out for the transmitter and it will still say it's transmitting at whatever because it's BS these days. But that's probably what customers want, BS. They've got enough knobs on them for BS, haven't they? Right, we've done that. We have done the power meter. Let's do the frequency. Let's pop that hopefully onto frequency. It's 27,79126, very, very slightly over. 27,79126, and the current consumption is now 1.12. So for 120 milliamps we've got another watt of power. So low power is adjustable on these sets, usually. Just check the S meter is or isn't. Second pair of glasses. On this one. I've said before that the presets in these sets are silver plated. If I go over this with my fiberglass brush, you'll see it doesn't make any difference. But I'm just wanting to point out that if I did that and do the deviation one there, they're actually real silver and they've tarnished with age. You won't get that quality today except with military parts. So on low power, let's go back to the low power scale and switch back to the main meter. We wanted 400 milliwatts, it's now doing 310, so we'll adjust that for 400 milliwatts on channel 20. That's another box ticked. I think this is going to work really nicely. So let's do the deviation on the test set behind. And this one can play up on the deviation meter. So we're now connecting up to the quartz lock 282A. We don't use this for receive because it doesn't go under VHF low band, which in the UK VHF low band is 68 meg start. Wallow. Wallow. Yes, about 2. Definitely needs to come up. Wallow. That's it. Turn that off. And connect back up to the main test set. And for giggles, we'll see what it says on here. Wow, it says just 2, so it's reading slow today. So 2.2 to peak of 2.5 kilohertz. We've done the RF meter. So now we'll put the signal generator on frequency, because it was set specially because the radio was low on frequency. There we go, spot on the same. And 100 microvolts on. We go to the oscilloscope and we set the detector, which can go out on this chassis, for maximum recovered audio. So the symptoms, if you don't do this, is either very quiet received audio in comparison to the background noise, or garbled recovered audio. Now it sounded not right to me, so I'm wondering if the IFs are out. So I'm going to do those first, which we don't normally do. So just put about 12 dB on the side, so we've got about 12 dB on the SINAD meter, a bit more than we normally have. Just want to check these intermediate frequencies, IF. See, that's 455 kilohertz IF. You've 2 intermediate frequencies, 455, the low one, that's its filter. And then you've got 10.695, in transistor radio it's usually 10.7. But it's 10.695 in most CBs. And there is another filter, if I could quickly find it, which I can't. It's there. Looks like a capacitor. They do have to be in the right way around, folks, as well. That seems right. Let's do that one. It's that one. I knew something wasn't right. Right, now we'll do the front end. Bit of improvement there. Drop the attenuator. Little bit of improvement there. Recheck this IF. Drop the attenuator, recheck this IF. There we go. Let's get some new readings. And remember to hold on to the radio. So there's 12 dB more or less. Let go of the radio and look how it dropped. And we've now got 0.47. What was the other set? 0.48. So we've beaten it. For 10 dB, it's 0.43. And for 20 dB, it is 0.75. Very, very similar results on receive, which is great. So we now want to do the squelch. So I'm going to turn the squelch to full. We're going to put the attenuator up on the inset picture. I want 100 microvolts for it to open. I'm going to adjust the squelch preset till it opens. So set threshold on the radio, signal generator is in standby. .42. Correction 0.46. And what does the meter now say? There's 100 microvolts, so it doesn't read 9 at that. So it's reading 9 at 150, 60, 185 microvolts. So that's improved with the IF being ironed out. 185 microvolts, still a lazy meter. And how does that compare to the other set? It was 190. So look at that, that was 290. So it's been very, very similar results, but we managed to get 4 watts out of it for what it's worth. We're done. Hey, that was straightforward. I'm going to change that socket. Okay, so we're back. So I've done that, and now it isn't pushing out. There was some wear on it. We'll connect it back up. And this time we'll connect it to the aerial instead of the test equipment. I'm quite struck by what condition these are in. Normally after 40 odd years they're a bit corroded on the lids. Whilst I'm screwing this together, why not put it on 19? The centre of dodgy activity. Can people remember the days when he went on 19, he said 19 for Fred Bloggs, or whatever his name was, and Fred Bloggs says, yeah, Roger, got you, and then he said, knock it up to channel 21 or whatever was free. Then he had a conversation. So when did this stupid practice of just talking on 19 come in? Oh, there's nobody on. No, nobody can hear you because of your big burner. About time there was some big smiting from the authorities. 19er Roger. Let's put it the other way on here. Roger. So we'll do the on the air test later on, and I think that's worked out really well, especially for it to do a full 4 watt output, which isn't going to be always achievable on every set. I've said loads of times the way this test set works, and it doesn't measure the interference, whereas a normal power meter is measuring the interference as well, so you get more power, but it isn't really on 27 megs. So there we go. Thanks for watching the Maxcom Apollo 16E, the second set from this customer, and they can go back to him now.